ABB Smart Substation Control and Protection SSC600 covers the protection and control needs of entire substations. And in addition to conventional centralized protection and control functionality, it also offers benefits specifically for arc flash protection. An arc flash is an electrical fault that results from a connection through a physical air gap or bridge between two electrodes. Arc flash incidents are rare, but they are the most dangerous fault that can occur in electrical installations and power systems. An arc flash can lead to severe injuries or even death, costly equipment damage, and long power outages. The main parameter of the electric arc, which characterizes its destructive ability, is incident energy. This is directly proportional to the arc duration and arc current. Without any active arc flash mitigation solutions in place, the arc clearing time may vary from 0.2 to 0.4 seconds. Within this short time, cable, copper, and steel can burn, melt, and vaporize. Therefore, it is of utmost importance to pay attention to arc flash protection. Arc flash mitigation solutions can significantly reduce the impacts, improve safety for people, and drastically reduce the time required to repair switchgear. One example is a protection relay that detects the light and current of an arc flash. When an arc flash is detected, the relay sends a trip signal to the circuit breaker to ensure the power is interrupted within milliseconds. Let's look at an example where we have an arc flash protection scheme that covers a complete switchgear lineup. In our example, we're using ABB's Unigear switchgear. The switchgear consists of 3 typical bays. The switchgear has truck-mounted circuit breakers and protection relays. There are also arc sensors installed in different parts of the switchgear to detect arc flash. Now, let's meet Matthew. He works as a protection engineer, and he is creating a protection scheme for the Unigear. If a fault occurs inside switchgear, it is essential that the protection decision is selective. This means that only the part of the switchgear affected by the fault should be isolated as quickly as possible. To do this, Matthew must integrate his protection scheme in the protection relay with selective protection, that is, zone-selective tripping. He also wants to include active arc flash protection with the relays, and he is using both light and current conditions in his scheme. Next, Matthew has to consider how to design the protection scheme if arc flashes happen in different parts of the switchgear. He has to consider that the switchgear has 3 different typical bays: incomer, feeder, and bus coupler, and they all have different configurations. In incomer bays, Matthew has to consider that if the arc fault is situated in the circuit breaker or cable end compartment, also the high voltage circuit breaker must be tripped. If the arc fault is in bus 1 or bus 2, the incomer must be tripped only if connected to the faulty bus. To accomplish this, there needs to be 2 arc lens sensors connected to the protection relays. Also, current information from both medium voltage and high voltage measurement points must be used selectively. Next, Matthew has to consider the feeder bays with a similar approach. Depending on where the arc fault is, in the circuit breaker, in the cable compartment, or in the bus bar, the selectivity logic needs to be prepared differently. To accomplish this, there needs to be 2 arc lens sensors connected to the protection relays, and the relays also need the current measurement from their own bays. As the next step, Matthew considers the bus coupler bay in a similar way. Depending on where the arc fault is, in the circuit breaker, in the bus riser compartment, or in one of the bus bars, the selectivity logic needs to be prepared differently. To accomplish this, there needs to be 3 loop sensors and 1 lens sensor connected to the relay in the bus coupler bay. Including both loop and lens sensors can be done with, for example, ABB's SSC600 protection relays. Next up, Matthew starts thinking about the interbay communication to plan the needed protection and wiring applications. To enable the communication between the protection relays, for example, sending and receiving protection tripping commands, you need to connect the relays to each other. This is done either with traditional hardwired signals, in other words, hardwiring, or by utilizing communication protocols. Matthew's protection scheme is now ready, and it is clear that building the system needs a lot of interbay wiring and engineering effort. If a similar system would be built with SSC600, however, the situation is quite different. With SSC600, there is no need for connections between the protection relays. The SSC600 receives all the current and light information from the protection relays, thus all the logics can be handled in a centralized manner. Further, selectivity logic is integrated into SSC600, which makes engineering faster and the switchgear easier to maintain. SSC600 also offers circuit breaker failure protection, so it is easy to increase arc flash protection reliability. It is also straightforward to add this kind of functionality as the logic is already in the SSC600 device. With SSC600, you can also have redundant communication to further improve the reliability of the communication system in this critical arc flash protection application. In a substation-wide arc flash protection scheme, with light and current conditions, an SSC600 base system has the same protection speed level as conventional arc protection solutions. This is achieved thanks to IEC 61850 based communication. There are many benefits of using SSC600 in arc flash protection application. Multi-application protection. In addition to arc protection, SSC600 can include all the needed protection functionality. There is no need for separate relay protection. Station-wide functionality. SSC600 also includes station-wide functionalities, such as station HMI and backup management. No separate devices are needed. Another example is the station-wide disturbance recordings in the SSC600. These are essential for post-fault analysis after arc flash protection has operated. Engineering efficiency. As the complete protection application is centralized, building arc flash protection with selectivity is fast and easy. Also, maintaining the protection application is straightforward. Safe switching operations. Local control and enabling protection are done via web HMI, thus decreasing the need for operative personnel to be in close proximity of energized switchgear. For increased safety when working near switchgear, the web HMI can be used to switch off current condition. This will allow faster reaction speed of the arc flash protection. Reliability. SSC600 supports redundant communication with PRP, Parallel Redundancy Protocol, which increases the reliability of communication in the complete arc protection system. Time and cost savings. Less wiring inside the switchgear and fewer engineering hours. Complete offering. ABB can offer complete arc protection systems including arc-resistant switchgear, light-sensing merging units, and even ultra-fast earthing switches. These can be offered as fully engineered turnkey solutions.